Hello students, welcome to E-Lessons. I am Shanmukha Shetty, your physics teacher. Now we'll try to look into specifically or more closer into the magnetic lines of forces or the field lines. That is, from where do they originate and in what direction they move forward, okay, what direction they originate and what direction they merge with the magnet, what are the properties of these magnetic field lines, all these things. Okay, so now you can very specifically draw the magnetic lines of forces around any bar magnet. Okay, that will be suggested in this activity 13.3. okay, so let us have this activity. This will be helpful in understanding how the magnetic lines of forces originate. Okay, you can physically draw the magnetic lines of forces around a bar magnet. Okay, so that is activity 13.3. For this activity you need a bar magnet, okay, and a white sheet of paper. You place horizontally that sheet of paper maybe on the floor and keep a bar magnet at the center of that. Okay, so this is a bar magnet. So this bar magnet we have placed at the center has poles. This is, let us say, north pole, and this is the south pole. Okay, now what you are going to do is, remember that it is kept on a horizontal floor. On a horizontal floor you have a big white sheet. Okay, at the center of that you have placed the bar magnet. Now mark the boundaries of these bar magnet. You can take a pencil and just mark the boundaries of these bar magnet. Okay, so you will have a rectangle in your sheet drawn. Bar magnet is there only. Now take up a magnetic compass. Okay, take up a magnetic compass and place it near one of the poles of this particular magnet. So I will place it near the north pole. Okay, this has to be done on a horizontal plane. You will be doing it on a horizontal plane on the floor. You have to keep the magnetic compass near the north pole. So now what happens? The magnetic needle will deflect. Okay, and south pole of the magnetic needle will be attracted towards the north pole. Okay, south pole of the magnetic needle will be attracted towards the north pole, and north pole will be in the other direction. So you mark the 2 points on that particular needle. Okay, like this is the south point and this is the north point of that particular needle, and remove that needle. Mark it as this is the south point and this is the north point of the needle. These are the 2 points. Okay, so these are the 2 points. Next, what you have to do, this at this point I will be having the magnetic needle, that is magnetic compass here. So here I will be having magnetic compass. Okay, the direction in which the needle is like this. This is the north-south direction. Next, what I have to do is I will move the compass to the next point. Okay, I will move the compass to the next point in such a way that now the south of the needle, the south point of the needle will be pointing towards the north. Okay, the previous north point. Okay, towards this point the south will be pointing and the north will be pointing in the opposite direction. Okay, so towards because again the north point is here, so south will be attracted to that. So you should place the compass in such a way that the south point of the needle coincides with the previous north point. This is the previous north point. With this previous north point, the new south point should coincide, and north point will be again on the top. Again mark those 2 points. This point is already there, this point you will mark. Okay, that is the another south point, the another point of the needle that you will mark it here. Okay, so this will be south. So likewise you continue this. Okay, likewise you continue this until you reach to the other end of the pole. Okay, so when you reach to the other end of the pole, you will be having again 2 points, one here and another here. Okay, now this will be the north end of the magnetic needle and this will be the south end of the magnetic needle. This is the north end of the magnetic needle, this is the south end of the magnetic needle. In between these two you will be having the magnetic compass. Here you will have the magnetic compass, and this is the direction of the needle. This is the direction of the needle. Okay, so you can continue this, right? So to have a whole set of points, Okay, this goes like this, and you will have so many such points which will form a loop. Okay, maybe like this. Okay, so you will be having so many points. That is, at every point we will be moving the magnetic compass everywhere. So everywhere you will be moving the magnetic compass in between the 2 points. This is how we will be moving the magnetic compass. Okay. So by this you will be having so many points that are marked on your white sheet. Okay, you can do this all around. Okay, many other points also you can mark, and also do it on this side as well. Okay, so finally when you take out this magnet, bar magnet, and when you remove this magnetic compass, what you are left with on that white sheet which was there on the floor is, okay, so this is how you have magnetic lines of forces. Now the direction of these magnetic lines of forces are important. They are from north to south. Okay, so the direction is from north to south. This is the direction, and here also from north to south. That is how the direction is. From north they will all be emerging out, okay, and they will all be merging to south. Okay, so this is the direction, and these are the field lines, magnetic field lines. They will all be emerging from north, they go all round, and they again merge into south. Okay, so all the rays or the magnetic field lines that are coming out of north are moving out, they are emerging out, and all the lines that are coming towards the south pole, they are merging into the south pole. So as you move away and away from the bar magnet, these lines get bigger and bigger. Okay, now this is what is happening outside the magnet. Okay, then what is happening inside the magnet is this particular field line. If you take up the magnetic field line, that is within the magnet, it is traveling from south to north. Okay, so actually one magnetic field line is a complete closed path. It's a closed curve. So likewise all these magnetic field lines, they are closed curves. Outside the magnet they travel from north to south, and inside the magnet they travel from south to north, and these lines are the magnetic field lines. Okay, the more crowded the field lines are, the more strong is the field, magnetic field around it. Okay, so the degree of closeness of these magnetic field lines indicates what is the strength of the magnetic field. More the closeness or more crowded the lines of magnetic field are, the more strength is there for the magnetic field. Okay, now another thing that you have to understand is this magnetic field has both magnitude and direction. Okay, the direction we have just seen. Okay, the strength of the magnetic field is measured in Oersted. The unit in which it is represented is Oersted. Okay, now there are certain properties for these magnetic lines of forces or magnetic field lines. That one is, it is a closed circular or closed curved path, right? It's a complete or closed curved path. Second thing is, no two magnetic lines of forces intersect each other. Why? Because suppose if two magnetic lines of forces were to intersect, okay, then what happens? Let us say that if this is one magnetic line of force and this is another magnetic line of force. Now suppose if you place a magnetic compass on this, okay, then what happens? At this particular point, if you pivot the magnetic needle, if you place the magnetic compass, then that magnetic needle should point in two directions, this direction as well as in this direction. Why? Because what are these lines actually? These are the lines. Suppose if I place a magnetic compass or magnetic needle on top of that, that magnetic needle will align itself along this line. So anywhere on this magnetic lines of force or magnetic field line, if you place a magnetic needle, that will align itself in the direction of the magnetic line, right? So if I place it at the point of intersection, suppose if they were to intersect, and if you imagine that you have placed the magnetic needle at that point, then it should point in two directions at a single point, and that is not possible, right? At a time, a magnetic needle will point in any one particular direction. So it is not possible to have the magnetic lines of forces intersecting. So no two magnetic lines of forces or magnetic field lines will intersect. They will never intersect. Okay, they will always be parallel. They can start from an origin and they can merge into it, but they can never intersect.